Hello, welcome to the Rust Language of the Future webinar that we are doing in collaboration between Brain Systems and Robot Dreams. Let me first start by introducing the contents of today's webinar, and then we can hopefully get into it and see what Rust is all about and why I believe that it's the language of the future. So we'll start with a brief introduction, then we'll talk a bit about Rust, then we'll talk about Brain Systems, which is the company where I'm from. Then we'll discuss why do we use Rust and what are the benefits and why does it make sense to invest into Rust not just as a hobby but professionally, and why we believe that it has a bright future in the industry. Then we'll discuss how to learn Rust, how we can help you learn Rust, and possibly even help you get a programming position with Braiins. And then we'll have some time for questions and discussion. So let me first tell you a little bit about myself. My name is Lukáš Ozda. I work as an IT methodologist at Braiins. I used to teach IT at the high school, also English language and psychology mostly as a tutor. I'm an open source enthusiast. I've been developing open source for many years as a hobby. I've been using Rust since 2015, which makes me quite an early adopter. I'm also one of the maintainers of Rust Awesome, which is, if you are familiar with all the lists that track what is good about a particular technology, language, or anything to that effect. So Rust Awesome is like that. And probably the most famous project in Rust that I have contributed to is the Rai language, which is an embeddable language like Lua, for example. It fills kind of the same niche, but it's written in Rust. And that's me on the right side. So once again, today's webinar is Rust Language of the Future. And first, let's start with a bit of background about Rust. How did we even get here? What led to the creation of Rust, and why is it important? And hopefully we will be able to derive from that why you should learn Rust and why it has great prospects in the industry. So let's talk in brief terms. Rust is a multi-paradigm language, pretty much like almost every other language that is used in the industry. It compiles the machine code, so we can compare it to C, C++, Go, and other similar languages, not to Python, not to Ruby. One of the main design decisions of Rust is that it likes to borrow from academic research that has been already accomplished many years ago, but it tries to take the discoveries from academia into a form that's usable by the common user. So take and add stuff so that it is more ergonomic, so that we can use it in the industry. It has some functional programming leanings, which we will also discuss a bit. It is not a fully functional programming language like Haskell would be, but it has iterators, it prefers immutability, it prefers to eliminate global state, but there are some functional features that you won't find in Rust yet. The main focus or the mission of Rust is to provide performance, safety, and concurrency all at once without making sacrifice in either area. It was created by Graydon Hoare, who is a developer, who used to be a developer in the Mozilla Foundation at the time, and now it's developed by the Rust Foundation, which is a self-standing entity. So first, a brief history of Rust. In 2006, Rust was created as a personal project of Graydon Hoare, The first compiler was written in OCaml, and the language that was created at this time heavily borrowed from its syntax and its features. Rust is surprisingly not named after the oxidation that develops on metals, but after a fungus. Grayden has provided a second etymology, and that's that Rust stands for robust if you skip a couple letters. In 2009, Mozilla decided to invest into Rust and start sponsoring its development because they wanted to use it in Servo, which is a new web engine. If you know, Firefox is currently using Gecko, then you have the Chrome engine. I forgot the name, but it's everywhere. And they wanted to create a new one in a completely new language, and ever since then there has been a lot of development on Servo and a lot of development on Rust that went kind of hand in hand. In 2010 they decided that it's no longer sufficient to have the old OCaml compiler, so they started to write a new one in Rust, for Rust, based on the LLVM project. In 2011 they finally succeeded. The compiler can for the first time compile itself, and for some time OCaml would still be involved. Between the years 2012 and 2014, Rust experiments with a lot of different features and approaches, some stuff that you might be familiar with from other programming languages like classes, garbage collection, interfaces, green threads, or if you know Go, then green threads are called Go routines in Go. Destructors, generators, all sorts of interesting features were added, and then later, usually in like a couple months or to a year, they were removed again because they did not mesh with the vision that was developing for Rust. At this time it was very difficult to invest into the language because it kept changing constantly, and breaking changes would be introduced essentially weekly. This changed in 2015 when we finally put together a philosophy of what Rust should be all about, and established some guarantees about backwards compatibility. 2015 is also the year that I started using Rust, and the original reason that I started using Rust was to torture my programming class teacher at the time, who unwisely said that we can use any language we want. I chose one that I didn't know, and I'm sure as hell she didn't know either. So now we're finally getting into the present. Between 2017 and 2018, a new version of the borrow checker was introduced. I'll talk a bit later about what actually is the borrow checker. And the main takeaway from this is that the Rust compiler started accepting a lot more code, so it became more ergonomic and it became easier to learn. There were some other quality of life changes, and the goal was to make Rust more ergonomic, because it used to be really very strict. There was this sort of philosophy that rather than accepting something that is incorrect and potentially unsafe, we will take the compromise of forbidding some stuff that actually would be okay. We just can't deduce that it would actually be okay. This culminated in 2018 when the Rust 2018 edition, formerly we would call them epochs, was released. And a great benefit is that the epochs or the editions are compatible between each other across crate boundary. Crate is a library or a program or a collection of binaries. It's like we can compare it to like a package essentially. And what this means is that even if there is code that was written with the 2015 edition, so in the 3 previous years, it still wouldn't break if you try to use it with new Rust. And this would be the case for every edition. 2019 was a major year for Rust because async programming, asynchronous programming features were finally stabilized, and that meant that we can now write applications that need asynchronous programming, which is typically network applications or other applications that do a lot of processing where you need to wait for some input from the outside. And 2019 is also the time where Rust became viable to us because we have this sort of requirement in Braiins, and we'll also talk about that later. In general, this was just a big win for the concurrency feature of Rust that its design philosophy focuses on. In 2020, WebAssembly started to become useful in Rust. It's still, to this day, is still not like 100% there, and it's still quite more difficult to write something for front-end in Rust than it is in JavaScript, but it is now possible to write a complete web application from bottom to top in Rust and share code between backend and frontend effortlessly. Constant generics were also added to the stable version of Rust, and that meant that we can now model more things with types. I'll talk a bit about it later, but it was another major feature because it allowed us to expand libraries to, for example, cover arrays of any size, whereas previously implementations would have to be, for example, up to 32 elements and so on. In 2021 there was another edition of Rust released. It was minor in comparison to the 2018 one. Generally there were some more changes for ergonomics and ease of adoption, and a couple warnings were promoted to errors because we discovered that there in fact was some cases that the compiler accepted something that could be potentially unsafe, and in order to not break anybody's code that may be in production, they were just introduced as warnings saying this is accepted but it shouldn't be accepted, and in the new edition it will not be accepted. And well, as I said, it's once again still compatible. Now we're getting to now, essentially. We're hoping for more generics, more and better async features. Actually, only a couple days ago a major async feature was stabilized, and more security fixes, more quality of life fixes and changes. I forgot to mention, you can ask questions at any time. I'll take a look at my phone every once in a while, and if I see a question mark, I will try to notice it and answer the question. There is not that many of us, so we can just take it easy and process it as it comes. So don't be worried about asking questions, just do it. If at the end I will take a look through the chat and answer anything that I have potentially missed. So here is the first actual Rust example. This is the quintessential hello world, and you can see that it is in some ways quite familiar. You see that it looks a bit like C or C++ or C#. You know, you have the curly braces, you have the semicolons, you have a main function that's actually called main, but there is some features that might be slightly unfamiliar. There is a very short keyword for function. It used to be the case in the early days of Rust that no keyword could be longer than 3 characters. That made some things sound really silly, such as, you know, if you are using loops, you know the break statement, so that's more than 3 letters, so they just did a break, and some other interesting stuff. It's no longer the case, but still in Rust most keywords are quite short. And then another interesting feature might be the exclamation mark here. In Rust, the println function is actually not a function, but it's a macro, and we'll talk in a bit what that means and why is it good. But if you're familiar with macros from C, C++, or maybe some other language that has more elaborate macros like nim, then this is also a macro. Now I have a slightly more complex example, and we'll also see how that works in practice. So this is a very simple program that asks you for a name and then doesn't say hello to the world, but to you in particular. You can see that unlike the equivalent in Python, for example, there is a lot more going on. It has quite a few lines, and there's quite a few things that might be unfamiliar. For example, all the thing about reading the line. Let's first see how it works out. I'll open my editor, and hopefully it will be readable. If it's not readable, then we can enlarge the font or something. So let me use the use statement to import something from the standard library, and let's see, how did I call it? I called it let mut name, which is a string. As you can see, I do not have to write the type of the variable. It can deduce it, and the language server protocol extension can show it to me what type Rust thinks this is. Then I can take the standard input. The double colon, it's essentially like in C++, it's a namespace. There is no such thing as a constructor in Rust, as a constructor method in Rust would be more appropriate. New is just a function, an associated function, just like any other. And we can see something like that. Enter your name. Here comes the complicated line of code. This is a very unhelpful tip, but there we go. And then we can just write it out like that. And that should be about it. So the Rust toolchain has a built-in package manager and build system called Cargo. And what you typically do is that you create the project as a cargo project from the get-go, and then you run code by typing cargo run. It will very quickly compile. I can say that my name is Lukáš, and it tells me hello Lukáš. As you can see, my name is actually correct even with the special characters that are not ASCII characters. That's because in Rust strings are Unicode by default. So you don't have to worry about locales and different encodings. I'm sure you have seen many applications that completely broke down your name because they didn't know how to handle the diacritics properly. I've ordered some stuff from Finland recently, and I've seen many interesting characters in my name. So what's interesting about this example, apart from what I've already said? Well, here's a short list. So, memory features, ownership and borrowing. So, or maybe let's start a bit earlier. So, you create so-called variable bindings with the let keyword, and that's essentially like variable in any other language, but by default they are immutable. So, once I have assigned something to the standard input variable, I couldn't assign again. It's read only. If I want to be able to write into some variable, I have to declare it so. And that helps to eliminate a common type of error, and that is where your code writes into something that it shouldn't be writing to. Once again, we have the print line macro to write some stuff into the standard output. If you are familiar with the printf function from C, you know that you have to use different formatting strings with the % sign. The nice thing about the print line macro is that it can figure out what you are putting there by itself. It would also scream at me if I promised something in the formatting string that isn't there. We can try it. So for example, I write this, but I forget this part. And if I now try to compile it, it's telling me I'm expecting one position argument, but you haven't provided any. And in C, no such thing would happen. You would find when the program would run, and it would be probably it would either write some garbage out or it would crash. So that's another, let's say, safety feature. There is this expect method that it really wants me to use after I read a line from the standard input. This is another part of Rust's design philosophy, and that it's that it forces you to at least acknowledge that some things may fail or that some things may not be present. So what expect does is it checks the result of this operation. It actually returns a type called result, and if it's an error, it will crash the program with this message. I say crash, but it's more like a graceful shutdown. We can actually try it. If I delete it and try to compile it, it will not be an error, but it will tell me, hey, you are not using a result, but you should, and this result may give you an error and you should handle the error, and if you really want to ignore it, you can do this. So the Rust compiler is quite chatty. It will tell you a lot of things. In some cases, it will even tell you how to fix some things. And it's one of the major features that people actually like when they start learning Rust, is that it will actually in detail tell you what's wrong or what could be better. So if I wanted to actually explicitly ignore it, I can do that. Now it will no longer scream, but on the off chance that it failed to read line, my program would not detect it. But this is fine because I acknowledge that it may fail. I just said I don't want to do anything about it. Now I mentioned ownership and lifetimes. So Rust has so-called move semantics, unlike C, which has copy semantics. And copy semantics means that when you put something somewhere as a parameter, it will be copied. But what happens in Rust is that it will be moved. So it will be taken from one place and put into another. So if I wanted to pass the name that I got somewhere, so let's say I do like a make name capital, or more accurately, print name as capital. I want to get some name. It will be a string. I actually have to specify the types for the parameters. And here I can do, I'm forced to use the formatting string, which also avoids an error that's common in C, that is that you are just print for some string and some smart guy puts % and formatting sequences into it and it crashes your program. And now if I do this, do uppercase, and I can actually call the function, print name is capital name. So this will work as expected. I can write Lukáš in lowercase. I see this is what I expected, and here it's in capital. But if I were to do something like this, print the name again here, not as capital. I actually try this, and made sure to close it because before it starts being read in the editor, so there is some suspense. You'll see that once again it's screaming at me and it says the value has been passed into this function, so its ownership was transferred over there. It was not copied, it was given there. And then you are trying to use it again, but you've already given it away. What gives? It does not work. You either have to make a copy or you have to make sure that you are not actually giving away the ownership of the value, that you are only lending it somewhere, or that some place is borrowing it, which is what this syntax does. Here we say, okay, the readLine function can mutably borrow the name variable so that it can store data into it, but I still have it. It's still mine, but I expect to get it back. So I could easily fix this if I just let it borrow the string. This is actually not the optimal way to borrow strings, but that's beyond the scope of this webinar. Now if I do it, it will not even show me any warnings, and it does exactly what I expected it to do. So I can let you borrow name, you can only borrow it as read-only, and if you are lending something to someone as read-only, you can give it to any number of places, but no one can write into it so long as it's being borrowed. All right, and that's it for this short example. Yes, there is one thing, and that's about Rust's memory model, and that is that we are actually making allocations here. This makes an allocation, this makes an allocation also. This also makes an allocation, this too. Or actually this doesn't, this only creates a view into the string. So, you know, in C you have to call malloc manually, in C++ you call new or something to that effect, hopefully. And then you have to actually make sure to return the memory to the system. Otherwise you're leaking memory if you're not freeing the stuff you allocate. Many languages, like Python and C# and Go, they solve this by having a garbage collector, which is, we can liken it to an entity that is going through your program and trying to see if something is still used, and if it's not used, then it will try to free it. If you've played Minecraft in its beginnings, you've probably heard of the luck spike of death, that the game would work all right and then it would lag extremely for like a brief moment, and then it would run all right again and again and again. What this was the garbage collector freezing the process to check what's used and what's not, and freeing the memory for you. What happens in Rust is that it analyzes your code, and at compile time it figures out when you no longer need something, and it automatically inserts the freeze of the memory. For example, okay, it knows here I'm making an allocation. It's still needed here, it's still needed here, still needed here, still needed here, but here it's no longer needed. There is no part of the code that would still be borrowing it, so I will put the freeing of the memory here. So it's automatic, which is really nice because memory leaks are pesky bugs that make it difficult to run things for a very long time if you're just very slowly continually leaking memory. And how does that? So we've talked about some safety features of Rust, and we can talk about them a bit more. So I've slightly gotten into lifetimes, ownership, and borrowing. Those are actually the most difficult concepts to grasp as a newcomer. So I believe that I didn't cover it enough in depth that you would be able to use it in practice. It takes time to get actually acquainted with the borrow checker, and as I promised, the borrow checker is the part of the compiler that checks that borrows are used in such a way that you cannot corrupt memory for yourself, that there is no pointer aliasing and such. Rust also has a strict type system with strong typing, so actually it's not easy to just reinterpret bits of one type as another type. It is quite explicit about its types. It has very good generics, and you can actually model a lot of things using generics in Rust. There is another thing, and that is that it's quite explicit and expressive. There is a philosophy that there shouldn't be any like black magic happening in the background, implicit conversions. If you've seen the very famous video on YouTube that's called JavaScript Sucks, that's essentially a 30-minute, very, very entertaining video, about 30 minutes of just showing the different bizarre behaviors found in JavaScript that are mostly due to things like automatic conversions and such. Rust does no such thing. It doesn't even want to convert numbers from one type to another. So if I have a number that's something like x and it's a signed 32-bit integer, like let's say 10, if I have a y that's like an unsigned 16-bit integer, and I say that z is x plus y, if I try this, it will scream at me because it says you are trying to add together two different types, and I will not do the conversion automatically. So you actually have to explicitly go and define the behavior of how types are converted. I actually only have one option here, and that is casting the y into I32. And now if I do it, it will no longer complain. It will just tell me that the variable is unused, and it will go as expected. There is a lot of compile time checks in Rust. You've already seen how the warnings look, that it tells you about unused variables and such, unhandled errors and so on. But it also has strong static analysis, which allows it to perform optimizations that make Rust very fast, on par with C and C++. So it makes it quite suitable in places where performance is required. And as we've seen, error handling is essentially mandatory because it's encoded into the type systems. There is no exceptions. Things that can fail return a result that either has the successful value or it contains an error. Things that may not be present do not return null or anything like that. They return an option that may either contain a value, so something, or it may be none. If you're familiar with none from Python, it's like a variant of an enum in this case. We can actually look at it. Once again, I can say that x may or may not be a value. So if it is a value, it's a sum. And you know, in C you would probably say, if it was a pointer, you would probably return null or something like that. In Rust there is no null. But if I now try to do this, it will once again complain. And it will tell me, you are trying to add an option to an I32. And you need to handle the fact that it's contained in an option. And I can, for example, once again do an expect. I can say this should not be possible. And now that I have done this, it will compile. Or alternatively, I can just do an unwrap which says, if there is something in the option, take it out so we can use it. If there isn't, just crash the program, going down. There is also clear separation between safe and potentially unsafe code. So all of this is safe code. It cannot do anything dangerous with the memory. I cannot cause a seg fault, at least not easily, and not easily on stable Rust, maybe on nightly. But I can essentially trust that this code will avoid the main issues that are concerning memory safety. If I need to do something that may be potentially unsafe and the compiler cannot help me by definition to figure out if it is safe or not, I can use the unsafe blocks, which let me do unsafe stuff in them. And the great thing about this is that the potentially unsafe bits are very clearly separated, and I can just search through a library and see if it has any instances of unsafe, and I immediately know that maybe something may be happening. It makes it easier to trust code you have not written. And thread safety is actually also encoded into the type system. So every type will automatically have a quality applied onto it, a trait implemented that will say this is safe to share across threads, or this is safe to send into another thread, which is a more restrictive form of the former. And I just immediately know if something is not, and Rust will not let me compile it and say, okay, you may do something that's very dangerous, that may corrupt memory because, for example, you are sharing some mutable state, and you need to make sure that something dangerous does not happen. So you are forced to acknowledge that something bad may happen and either handle it or say, all right, I'm ignoring it, but it's my conscious choice. And I believe that's quite important in production, where you actually want to know what risks you're taking. So why is this important? So according to Ryan Lewick from Microsoft, 70% of CVEs, if you know this CVE, it's like a large repository of exploits and vulnerabilities that are discovered in software, are caused by memory safety issues, different forms of memory corruption typically, some buffer overflows and so on. These things are something that is not possible in safe Rust. It will be prevented, or the possibility of it happening will be detected at compile time. For example, if you have heard a couple of years ago, there was this large exploit called Heartbleed. Heartbleed was in the OpenSSL security cryptography library that's used everywhere. Every device that you've probably held in your hand probably has a version of OpenSSL on it. Even the router and all sorts of devices. There was an error where you could do like a handshake with the server part of the library and say, all right, I'm sending you this string has this many characters, and you send it to me back. And you could, for example, say, all right, I'm sending you the string hello, it has 500 characters, send it to me back. And that's clearly out of bounds, because last time I checked, there is not 500 letters in the word hello. And what would happen is that OpenSSL would just read memory that it wasn't supposed to and send you back data of its internal state, which was sometimes private keys and other cryptographically sensitive information like passwords. And it was actually quite serious. It had to be patched very quickly, because you could just tell anybody's router to send you the password, which is not very secure by my estimation. The thread safety features are quite important because it is very hard to write multi-threaded code safely. It is very easy to corrupt your memory, very easy to run into data races and race conditions, while also maintaining performance. If you have something like Python used to have. It was called the GIL, the Global Interpreter Lock, I believe it stands for, is that it would just keep locking your process to make sure nothing bad happens. That is quite costly to performance. As I've mentioned, Rust's features are mostly compile time, so the code will still be fast because all of the checking and possibilities will be explored while the code is compiling. That makes it compile slightly longer than many other languages, but it's not too bad. It is also important that you can actually just trust foreign code more than with C, for example. And all of these vulnerabilities and risks and errors, they add up to millions in damages when something bad happens in companies, and some app crashes, there is some corruption or memory, and something bad happens, or some security leak, and that's costing millions and millions. And as I say on this slide, that money would be better spent on company breakfasts. Now, a couple other hallmark features of Rust that we have already touched upon. So there is the focus on performance. There is Cargo, which serves as both a package manager and build system, which makes it very easy to pull in dependencies, manage them, and it also makes it very easy to publish your code, which is quite good for open source. It can be compared to Node's NPM or Python's pip, but in some cases it's better, in some cases it's more simple than those solutions. And that lets you avoid dependency hell, which is something that happens quite often in languages that don't have a native package manager. You can also use Cargo to just install software to your computer. There are also built-in features for documentation and testing, which are really important in commercial setting. That they are quite tightly integrated. Rust handles documentation as so-called documentation commands, and you can have code snippets in the commands, and it will actually verify them every time you compile the documentation. It will verify them against your code to ensure that it actually is still valid. And then there is a focus on performance. The zero-cost abstractions, that's essentially what I mentioned, is that all of the static analysis and all of the checks are performed at compile time. There is the OOP situation. Rust is object-oriented, just like most languages used in the mainstream, but it prefers the composition model over inheritance. You don't have classes, you don't inherit from one class to another, but you composite different pieces of behavior, sort of like interfaces. They're called traits in Rust. And you are describing objects based on different capabilities they have, as opposed to like a hierarchical structure. It's good for many applications. It's not good, for example, for building GUI frameworks. So it's a bit of a trade-off, but I believe it works quite well. And the composition model, as done in Rust, also likes to separate data from implementation. So you don't mix and match methods, properties, and fields. As I've said, with the expressiveness, there is almost no implicit behavior. It will not even convert numbers automatically. So you can actually just take control of every part of your program, which is also important if you want to write robust software. And Rust is quite well tested. There is a thing called Crater, which just tests on everything Rust that's available on GitHub for regressions. Then there are different channels of Rust, and there is always like a period of, all right, now we'll test this from nightly to beta in 6 weeks, and only after another 6 weeks we'll stabilize it, just to ensure that there is like no issues. So it's actually, there have only been like a couple bugs in releases that would require like a hotfix or something. The functional features, there is a preference to iterators over loops. There is patterns and pattern matching with the match statement, which is like a switch in different languages. We can very quickly see. For example, I have the Z here, and I can say match Z if I can hit the key properly. And maybe some cases, then I'll say, for example, if it's 10, which I know it's not, we can say this is 10. If it's 20, I can essentially say something that's quite similar. But if I try to do this, it will not compile. It will very loudly complain at me. And here it's telling me this is not exhaustive. That's a bit of an oddity about Rust. If you have a match, you have to cover every possibility. But it's also about the expressiveness, it's just taking care of everything. So I have to say, all right, in any other case, I just want to call it X and say it has this value. And now it will no longer complain and it will compile just fine. This is very useful if you are, for example, matching on some sort of messages that are coming to you over network and you have an enum variant for every possible message. And then someone comes and adds another message, and well, you'll suddenly find out that if someone sends you that message and you're not covering it on the receiving end, interesting things may happen in your application. And this will essentially enforce that once a variant for another message has been added, all of the matches that do not cover it will start complaining that, hey, there is a possibility that you haven't covered. And you either need to ignore it explicitly or you need to cover it. The Rust toolchain also has a built-in linter, formatter, language server, and some early code coverage features. It can also cross-compile, and as we've seen, it has excellent warnings and errors. It will also detect the typical joke with a Greek question mark, which looks just like a semicolon, except it's not a semicolon. So it's a very fun joke to play at your friends to replace their semicolons with question marks, Greek. Now, a bit of background about Braiins, very briefly. We are a company in the heart of Prague and hopefully also in the heart of the Bitcoin mining industry. By the heart of Prague, I mean Karlín, of course, which is the best district. This is our logo. This is also a logo, different color configuration. We were founded in 2011. As I said, we're in Karlín at Křižíkova. We mostly focus on embedded development throughout the company history, but later we shifted to facilitating Bitcoin mining. We don't actually mine ourselves, we develop firmware, we operate a pool, firmware that's the Braiins OS Plus as listed here. We also work on designing a secure and reliable network protocol for mining and tools for managing a farm, such as the farm proxy or toolbox. And recently we got into hardware development and we're starting to design our own hardware. We already have a couple prototypes and we even published a control board released a control board recently. Other than that, we have a publishing house. We publish books, mostly about Bitcoin or about economics. And we also try to educate people in those areas. And hopefully now we'll start to educate in technology and IT also. So that's my responsibility. I do the technical education at Braiins. If you are interested in working at Braiins, you may want to know what sort of technologies we use. So this is mostly for the people that are interested in working here. We have the classics. Of course, we use Git. We're not savages. and Docker, GitLab CI, Kubernetes recently. We've heavily invested into Prometheus and Grafana for metrics and in our code. Recently we also started building things with Nix, which has been a great experience. And for the actual technologies, front end, everything we have is TypeScript with React, and backend is Rust and Python. And all the backend embedded tooling, it's all Rust and Python. Essentially Rust is everything, only some old legacy code is Python, so we've went full in. Yeah. How do you like working with Rust macros? So the Rust macros used to be quite unwieldy. The situation has gotten much better, and you can actually do some quite impressive stuff with macros in Rust. And I much prefer it over C macros. There are languages that have better macros, like all of the Lisp adjacent languages, and Nim possibly also. But in Rust it works quite well. I've used it to great effect, both declarative macros and procedural macros. A procedural macro is essentially a program that receives some code on input. You can do anything you want with it and spit some other code out. It's procedural, actually. And there, in probably not foreseeable future, but future still, there is a macro rework coming to Rust that will make the situation much better. Is there anything you miss in Rust? Well, not in particular something that I would miss from other languages, but there is a couple features that are still only nightly and haven't been stabilized, so that I'm quite excited for. There is, for example, generators. There were asynchronous traits that were only very recently they were stabilized. I'm not sure if it was in the last release or if it will be in the release that's coming now. That was a big pain point. And then some quality of life syntax features that I'm quite excited for, mostly syntactic sugars to make my life easier, to make Rust even more ergonomic for newcomers. What features of Rust are essential for Braiins? So, because we do embedded, we have to be quite particular about the way that we handle memory. So all of the memory stuff with Rust, you know, the concepts like lifetimes, ownership, borrowing, the fact that it has manual memory management and not a garbage collector is quite important. The safety features also, because you know, if we put an embedded device somewhere with our code, we really want it to be reliable, and we want to make sure that our code will run, that nothing unhandled will happen, especially when it's like firmware for the hardware that we are starting to create. And then from the other side, asynchronous Rust has been essential for our network infrastructure. We've been able to create parts of the Braiins pool that are extremely great at performance. There is very low latency, and we have achieved results that just were not possible in Python. Yeah, that's for that. How did you learn Rust, and what other languages did you know before then? I learned Rust at first the wrong way, and that is by jumping head first into it, which is not a great experience with Rust. I do not recommend it. You will get frustrated, you will get angry, and you will want to do unspeakable things to your keyboard and or monitor. The correct way, which I soon learned, is to actually learn a bit more about Rust before you start doing Rust, or at least take it hand in hand, the theory and practice. It's just not a language that you can jump headfirst into. And so what I would do is I would read the Rust book and some other materials that were available at the time. There weren't that many materials available at the time, and it was still quite difficult to learn Rust. but in the end it was very worth it. Before that I used mostly C, C#, and all sorts of other languages. I was a bit of a programming language enthusiast, so I just kept trying everything, including very obscure ones. Of course, I used the common ones like Python, Java, and so on. PHP, God forbid. And since then, I essentially settled at Rust, but I still explore. It's a passion. I'm quite passionate about programming language design. I'll actually speak about the learning a bit more soon. I'll just quickly go over why we use Rust in Braiins. Well, it's because it has everything we need, which is, I answered that a bit in the previous question. So there are some domains that are very suitable for Rust. One of it is OS development. Rust was even merged into the Linux kernel some time ago. Then there is systems programming, because if applications are depending on your code, if other code is depending on your code, you probably want to make it robust, so that there is one less place to worry about. And Rust is quite good for that. It's also good for developing performance-sensitive applications, which is the case often in systems programming, that you really want to make sure that your bit is not the bottleneck. Then, because it's, let's say, a direct competitor to C and C++, it is also suitable for low-level programming with its manual memory management. Unlike C, we can have some nice high-level features without sacrificing performance or requiring something like garbage collector, because it's low-level and because it's without a runtime and because it can compile down to the necessities. It is quite well suited to embedded. There is a lot of development going on with adoption of Rust in embedded. We are one such case. And as I mentioned, asynchronous network programming, when you need to write some networking servers that need to be low latency, high performance, responsive, and also need to be robust. NPM, Node Package Manager, and the whole massive register, I still believe it's the largest in the world, actually rewrote some mission critical parts of its infrastructure in Rust so that it is reliable, performant, and doesn't crash. And all of these domains are something that we are focused on in Braiins. There is a couple other benefits that led to the decision to use Rust. We want to avoid issues with managing dependencies. We would have to use C probably, if not Rust, or C++, and everybody knows that getting the different tool chains and libraries working together can be quite difficult, especially if you're working with an obscure platform. We also want to ensure a certain code style, formatting, and certain choices. The built-in linter clipper can help with that. You can actually configure quite a lot of things. You can even use it to forbid particular functions or methods. If you just want to make sure that, all right, no one will call this one method that will just crash the code without any message. If you want to do that, you have to include a Y so that we can track it down if it crashes in the hands of the user. So we can actually debug it. We also want to be able to trust third-party code more, and the clear separation between safe and unsafe and all the other strictness of Rust helps with that a lot. And well, we want to actually focus on the projects and the actual development on that, not have to worry about debugging pesky memory safety bugs. And in our case, composition-based object-oriented programming is quite handy. So, how does a typical workday looks like for developers at Braiins? Well, we are not a particularly strict company when it comes to how you manage the time in your day, so long as things keep working. We really don't have any micromanagers. So typically you will probably have a stand-up to give a quick update to your team leader and your colleagues so that everyone knows who is working on what and how different initiatives are coming along. And then you will probably spend your time hacking away at some tickets. Generally, developers have some sort of agency when it comes to choosing the approach they use for solving a particular problem. We don't really like, it's a mean term, but we really don't like code monkeys who just perform instructions given. We like developers to have some sort of freedom and to be a part of the decision-making process. Maybe you will have a couple meetings in a day also, and lunch, hopefully. So that's like the gist of it. Other meetings and stuff, it's like not prescribed. It's mostly when it's needed, can be set up. We are quite flexible in that aspect. There is like an overreaching philosophy of if things are working, let's just not bother people and put obstacles in their way. What is the recommended roadmap to learn Rust? I'll get into that in another slide. Do you do anything to ensure correctness of your code at Braiins? Property-based testing, fuzzing, type system extensions. So we have some fuzzing out of these three. We have not found a reason to look into type system extensions in Rust yet, because in most cases we can actually use Rust's generics to constrain things quite severely, so we achieve what we would have in some other languages needed a framework for. And as far as testing goes, it depends from team to team. I cannot tell you exactly which team does what tests. I am not sure that anyone would be doing property-based testing per se, but I don't read tests generally. It's developers do, I don't. Did Braiins contribute to Rust somehow? We haven't contributed to Rust as in the language or the compiler directly, but over the years we have discovered perhaps some bugs or some missing features in libraries in the community. So we would patch them, and generally respecting the GPL open source license, we would offer the changes to the upstream, and it worked quite well. It's an ongoing process, so sometimes we just fix something in some framework and we offer it. Sometimes it's accepted, sometimes it's not, because it doesn't align with the vision of the authors of that particular framework, but it depends. Who is definitely not Zoltan? That would be an analyst at Braiins. He's a really nice guy, and I suspect a colleague of writing this question. What do you think about Zik programming language being, I hope that's being because there is a heart emoji obscuring the last message, possible substitute for C in this future? Have you experimented with Zik at Braiins? We have not experimented with Zik at Braiins, but I have experimented with Zik in my free time. It's a very interesting language. It has some features that I find quite interesting, and I think that it fills some of the same niche that Rust fills with relation to C. There is of course the issue of safety, which I believe is still not as good with Zik, and I don't think it's part of their mission either. But as I spoke earlier about the macros and metaprogramming, there was a question about it. Yeah, I think that Zik has better metaprogramming than Rust, so that's definitely one area that makes Zik quite interesting. And I actually quite like that there are other languages that challenge C and C++, because if nothing else, it brings competition into the industry, and competition, hopefully, as in every other industry, breeds innovation. And now, alright, so there is no more questions now, so we can push on to actually learning Rust, which a question was about. Rust is known for having quite a steep learning curve. It is a bit deceptive because the syntax looks quite familiar, but semantically it's really not familiar. There is the move semantics I mentioned, so it can be a bit overwhelming in the beginning. And I have a couple points here about how to actually approach Rust. I recommend reading a book and or enrolling in a Rust course. We'll actually be starting a Rust course at the beginning of October. I'll speak about that later in a bit. From the books, probably the definitive source is the Rust programming language, which is actually part of the Rust project. It's written by the people who develop the compiler and write the language, and it is written really well, but it's also quite thick because it goes really into detail and tries to really make things palatable if you're not familiar with the concepts. Rust also has a pretty great community when it comes to getting help. It's very active. There is like 2 massive Discord servers. The community on Reddit is also quite nice, and on the official forums, and even IRC, there is an active IRC community with Rust. It is usually quite easy to get help quickly when you have an issue within the community. And well, the last, more like a philosophical tip, is to have patience and to take things slow, because it can be tempting to immediately start building castles in the sky and say, all right, I will write a Minecraft clone in Rust. And I think that really the better approach is to just take it small, try small things first, things that are manageable, things that you can tangibly conceptualize in any language, and then you can just slowly build your way up. As I've said, it's not a good idea to jump into Rust head first. It's also not a very good idea to try to write Rust the same way you would write your favorite language at the time, and just try to force things to work your way. If you're having a lot of difficulty, a lot of frustration getting something to work, then you are probably doing it wrong. And you are probably doing it wrong in a way that's somehow unsafe or unidiomatic. And the difficulty is just Rust's gentle way of reminding you that there is a better way to do this. And eventually it becomes second nature. So it's not like a forever burden that you just be constantly frustrated. You just get it eventually, and then it's quite pleasant, and then it's also starts becoming your favorite programming language, perhaps. This is a bit of a joke is that there is 3 stages of learning Rust, inspired by the 5 stages of grief. First there is the denial, that you can think that Rust is quite familiar. You think that you can do a lot of things very quickly. That will not be the case. You will very soon learn the name of the borrow checker and will be complaining, why is it bullying you? Why is this not allowed? What the hell does this error even mean? As you start just building bad code on top of one another. Also, a very familiar question is, why is it so hard to implement a linked list in Rust? There is actually an entire book, I believe it's called Learning Rust entirely by implementing linked lists. Why won't matches and results leave me alone? And there's a good reason, because they shouldn't be left alone. And that can make you quite frustrated, quite angry, especially if you have no support framework and no one to discuss it with. But eventually it will just click, and you will see the borrow checker not as the evil bully, but as the mentor, as the sensei to the ninjas, samurais, whatever, Kung Fu Panda. And it will just click, and you will see that things can actually be done quite well. They can be done reasonably quickly, although I have to admit that Rust is a bit slower with the speed of development. You can write things in Python very, very quickly. In Rust it will be slower, but the code will be faster and more maintainable. And those are the 3 stages of Rust learning. Now, what I briefly gotten into is that competition hopefully breeds innovation, and the way that I hope it will happen is that other languages like Rust will start to pop up and challenge the space. Rust has great prospects. It's starting to be developed, adopted, A, by startups, and B, by massive corporates like Microsoft, Facebook, Google, because of the features it has. So it seems that out of all of the C competitors, Rust has quite a bright future ahead, and hopefully we will be able to see some real innovation. And I've included a small meme about God's perfect creation, the C++ developer, which has probably changed less than C++ itself. It just becomes bigger and bigger, C++. There is, I believe that the last C++ standards has like 1500 pages, and that's A4 format. So you could probably just kill someone if you clobber them over the head with it. And that can make it quite difficult to actually get into. Now, let me just quickly, because the YouTube app crashed, let me just quickly reopen the comments to see that I'm not missing anything. I am thinking about a project for our group in school to code in Rust because of the speed, to get familiar with it. Am I mad if I want to create a web app purely in Rust? You are not mad. If you have the time for it, it is perfectly manageable, and it will also be worthwhile because it will feel very cool. And I have done that before. I've made a couple of small web apps that were written entirely in Rust from top to bottom. I even had styles and HTML generated from Rust, so it is possible. But you say that you are thinking about a project for your group, so make sure that your group mates are also on board with the idea, and that it will not be too much for them. But otherwise, yeah, go for it. Perfect idea. Thumbs up. Good luck. Yeah, and as I mentioned before, learning Rust pays off. I have a quote about the Stack Overflow survey. Rust was the language that respondents most admire, with nearly 85% of the developers who had used Rust saying they want to continue using Rust in the future, compared to 58% for JavaScript and 66% for Python. If you look at the graph, there actually is quite a noticeable dent between the first and second place, so it really seems to hold a special place in the hearts of developers who start using Rust. That's the case with me, but I'm a hardcore enthusiast for quite some time now. So even if it can be difficult in the beginning, it pays off, and there is like it's probably the most common meme in the Rust community, and that's just suggesting that everything should be rewritten in Rust to make it better. And many things end up being rewritten, and often they are better. Generally, they are at least faster. Often they are even safer, and then people just start developing nice features, and it really is nice. Now, I've mentioned previously that enrolling into a course is a great idea for learning Rust, because you will be able to have the interaction that's really helpful in the learning process, and your entrance into learning the language will be guided, so you will not experience as much frustration, and you will be able to actually learn Rust enough to be productive in a way that's not painful, and that's also reasonably quick, as fast as we can make it. Oh yeah, let me first answer. Do you have the capacity to hire junior devs roles as well? As companies are usually looking for experienced people who know Rust. So it depends on what you mean by junior. If you mean by junior people who do not know Rust, but who are developers, yeah, at least the case in Braiins is that we don't really consider it a deal breaker to not know Rust beforehand. We actually, and that's part of my responsibilities, we help newcomers learn Rust. We do not hire people based on their knowledge of Rust, and as I mentioned, or it's definitely mentioned in the materials surrounding this webinar, is that for the people who successfully complete this course, there is the possibility of working in Braiins, and that makes it really helpful, because I will be able to just focus on you and teach you Rust full-time within the scope of a course, and then you will be able to come work with us, and you will know Rust already to the point that we believe is good for production use. But in general, us, and I believe even a number of other companies, at least in Czech Republic, where the community is not that big yet, companies are perfectly willing to go for you even if you do not know Rust. If you mean junior, as in you've never worked in a commercial setting and you do not have the soft skill yet, then it just applies like in general whether we are willing to hire junior devs for a particular project or something, and that's something that depends from team to team. Currently in Braiins we don't have that many juniors, but it's something that we are looking into expanding in the future, because we'd like to have like the full spectrum from juniors to mediors to seniors. And at the moment we are a bit top heavy. We have a lot of senior people and we don't have that many more junior people. So the lecturer of the course is once again me. I think that every good presentation has at least 2 photos of me, so this is the second one. There will be 20 live online lessons from 3rd October to 14th December. This is the program. I will not read it out loud because it could get quite long, but I'll just very briefly show it here. You can pause and rewind the video when we are finished to look at it, and it's also available on Robot Dreams website. There will be a QR code at the end of the presentation. Oh, this is it. As you can see, there is not that many things in scope for each particular lesson, so that we can focus on one concept and do it properly. There will also be homework during the course of the course, which will focus on developing a complete project that you will be able to include in your portfolio, in your CV. And there will be also some sort of feedback. There's a question: how do you profiling in Rust? We use the exact same tools that you would use with C and C++. It's all compatible. I can remember that we've had some experience with gprof and flamegraph. Then there is also some experimental profilers written for Rust in particular that I played with, but I don't believe we've used them in production, in Braiins. So it's compatible. The same goes for debugging. You just, with the same tools that you use to debug C, C++, you also debug Rust. The Rust toolchain has some very nice wrappers to make sure that, for example, the GDB debugger formats the output nicely, so that you can actually look at it quite well. Even perhaps if you've heard of RR, that's a time-traveling debugger that records every source of entropy in your program, and you can replay and go back and forth through the run of a program and create divergent futures. It's developed for C and C++. It also works with Rust, and I tried it and it works quite well. Although multi-threaded code is very slow with RR, but it works well. So, because we can leverage the tools that have been there for decades, the situation is quite mature. Hopefully, we will get to that point with code coverage yet. It's starting to work. We have introduced code coverage in a couple projects, but it's still quite new, even though the situation is improving, and it works well. Yeah, it's just new. So this is we're almost at the end here. As I said, it's 20 lessons, and this would be the final part of the program. In the last lesson, we will take a visit here to the Braiins headquarters at Křižíkova. We also do like an in-depth review of the project we have developed together during the course. Right, so here is the promised QR code to the course. If you use it, you will get a 20% discount. So it's an exclusive offer. Once again, you can stop the video and the recording will be available. I'm not sure if the slides will be available, but it should still be good enough to scan. Yeah. All right. I've spoken a bit about the format already, but as I said, the courses are courses made by Robot Dreams in general, and mine will be no exception, are live and online, so you can join them from anywhere. The times are written on the website and the exact dates. There will be a 2-week break in November, I believe. You can track your progress, and ranking with your classmates, but most importantly, we will operate as a community, and you'll be able to discuss with me and classmates, which I believe is extremely important for the learning process. It really helps to get the things down, and afterwards you will retain everything. Yeah, as I've said, there'll be a Discord server. All right, so about RoboDreams, I'm not from RoboDreams, so hopefully I will do them justice in introducing them. They are an educational IT platform. I believe they've been here for about 8 years, if that's correct. They create all sorts of courses adjacent to technology. As you can see, they have data analysis, programming, data science, machine learning, and they are taught by top experts in their fields, such as me. And their graduates successfully find employment. That will be twice the case with this course, because we are actually trying to look for employees with the course. So it's our stated goal. We want to do a course, and we would like to take in the people who complete the course and fit our company culture. And there you can see a number of logos of where the lecturers work, I guess. All right. And now we have a final time for questions and answers. It can be about anything. The course, the Rust, Braiins, my hairstyle. So please ask away. And that's probably all that we will have for today. So now a couple minutes for questions. And then we can call it a night or an evening. Just take it so that I can actually read them well. You can also find me on LinkedIn with my name, and that's probably a good platform to message me if you have further questions. There is also a place to ask questions about the course in the link that's provided in the YouTube chat by RoboDreams. So that's about that. Hi, I was learning just HTML. Hi, I would like to work for Braiins, but I was learning just HTML, CSS, and started to study JavaScript. This looks for me too complicated yet. Does it make a sense for me to pay for the course? Well, I'm not a salesman, so I cannot tell you with certainty. I suggest that you look into the description of the course and see what each lesson is about and decide based on that. I have heard an argument some time ago that it might be easier to learn Rust as a first language than as a language after a number of languages, because you will not be influenced by habits you have picked up before that might be conflicting with the way things are done in Rust. So maybe there is some merit to that. I think that if you've got down the basic programming concepts, even from JavaScript, and you understand what is a type in programming, and you learn the basic concepts of memory management, which is namely what does it mean to allocate and free memory, what is a pointer, that's essentially it. Oh yeah, what's the stack and what's the heap? Those are probably the prerequisites that you should know. Then I think that there is merit in learning Rust, and the course maybe for you. But as I've said, look at the website, go through it. If you have some specific questions, you can also ask me on LinkedIn, or if you dig up my GitHub, there is a couple ways to contact me. But yeah, for what type of projects would you recommend Rust, and for which you really don't recommend it? So I think that it's good to start with projects that work with the command line and don't have a GUI, because as I mentioned before, when it came to the different models of how you can do object-oriented programming, you are familiar with inheritance-based, Rust has composition-based, JavaScript used to have prototype-based, prototyping OOP. GUI graphics like Windows and so on, they're a bit more difficult to do with composition. It's a bit more involved and it takes a bit more effort and understanding. So that's something that I would not recommend, but otherwise, when it comes to CLI applications or web backends or some other utilities and all the toy projects that are common, there is almost with every language that we ever thought. In high school we would do the hangman game and guess a number game. So these simple things are quite good. I know that there are some people who have had luck with file processing. Writing a Lisp interpreter is also a pretty nice project to do if you are interested in developing programming languages. But yeah. What is the expected time commitment outside of webinars? So outside of the lessons, which will be twice a week, I think it's an hour and a half each one, yeah. It will be a couple hours a week. That's for the homework and perhaps reading the materials again. Of course, there is also the option of speaking to me and others, and how much time you decide to dedicate to that is up to you. I cannot prescribe it like now you will talk for 3 hours with your classmates. So I don't think it should be too expensive, and there will not be a case where homework would be scheduled right for the lesson after it. So you will not be in a hurry. I don't want to create unnecessary pressure that could interfere with your daily life. What other companies in Czechia use Rust for development? I know just about Braiins and Satoshi Labs. So yeah, all the that's probably the major ones. There is a couple of startups. Then I think Kraken, the crypto exchange, has a office here, and they use Rust. Unfortunately, Kraken is not really, owing to the nature of their work, they are not really beginner friendly. They actually require you to know Rust quite well and to be a senior developer in other aspects than just knowledge of Rust. So they're not as beginner friendly, but they are probably like the third biggest after us. Yeah, it's a growing market. I know that some other companies from the industry, Bitcoin industry in Czechia, and some others have been looking into Rust. Yeah, so let's maybe do, how many questions do we have? We have 2 questions, so we can do them and we'll call it a night. How will you tell if someone who enrolls in a course is a good candidate for a job in Braiins? Well, mostly by completing the course. So That's if you complete the course, then I think that you are at least technically eligible. Then based on just how we talk, I will recommend the people who I think would be to the company, and hopefully it will work out. And by great fit, I don't mean like from an HR standpoint that you know, you are just who we want, but I also want to take into consideration that as I get to know you, that I will be able to discuss with you if Braiins is something that you want, if it's something that suits you. So I like to have a human approach, let's say. Are you developing UI parts of apps in Rust also? No, we use Electron so that our front-end boys can reuse stuff that's used on our website, and we have a coherent design language across every product in our websites. It might have been asked before, is the course in English or Czech? It's in English. And that's it. I thank you all for attending the webinar, and I hope that I might see some of you in the course, or at least on LinkedIn if you have further questions. All right, thank you all, and have a nice evening.